Good morning. My name is Will. I am a researcher with Horizon Blockchain Games, and we're trying to make video games that use the blockchain. Yeah, so thanks to Parity for organizing this amazing event here in Berlin. It's really quite nice. So first, I'll just give a shout out to my our team. We're mainly based in Toronto, but we actually have people all around the world. So in a lot of ways, we're like a distributed organization. But the thing about making video games is that we're actually like a pretty multidisciplinary team as well. I mean, we've got all sorts of different people. Like we've got not just developers, we've got a lot of designers and artists and musicians. It's really quite a creative endeavor. So what are we trying to build right now? Well, we're trying to build a trading card game from another dimension. And we're calling it Skyweaver. So the idea is that Skyweaver is a trading card game, so you can trade cards, of course. But the premise is that good players might also be able to earn cards as well, to earn rewards just by playing the game. And using those cards, they can battle their friends or other Skyweavers online. And actually, this is a browser game. This is running direct in the browser. It would be able to, it's able to run not just on the desktop, but in your phone as well. So the thing about trying to create this game is that we found that there's a lot of different pieces to it. So we also have to build the infrastructure for this type of game because there's not really a whole lot of similarities to like conventional like AAA gaming. We have to build a lot of things because we want to incorporate blockchain elements into it. Which brings us to the sort of infrastructure that we're also trying to build, which is called Arcadium. So Arcadium is our vision for what a virtual arcade would actually look like. When it incorporates blockchain elements, things like the items that you own are actually things that you own, right? Because this is why we came to blockchain. This is the core thesis of what ownership is. So Arcadium is not just something for gamers, but it's also something for game developers as well. We're building a lot of this infrastructure, which is tooling, user tools as well. For example, wallets, game libraries for developers, exchanges where players will be able to actually exchange their game assets for other things, not necessarily other game assets, but also for other cryptocurrencies. So that brings us to the question, okay, so why Substrate? So as I mentioned earlier, players are going to be able to also earn rewards through gameplay. And the key idea is that we want to make sure that distribution of rewards is actually done in a fair and objective manner. So in order to give rewards to the winners, we also need the game logic of Skyweaver to exist on-chain as well. So what we want to do is we want to apply Substrate as the engine that runs the game logic, verifies those results, and then ideally mints the reward that the player or the Skyweaver will actually earn. So what's the classical approach of doing these types of games is to construct a state channel where you start from initial state, and then every game sort of goes through this sort of process where you apply a series of moves, and then eventually you get into some terminal state where obviously there's some winner, some loser, or maybe there's a draw. But the core idea is to make sure that all of the moves are signed so that you have some authenticity over the fact that these moves are actually made by the player that claimed it. So in this core approach, we can just take these moves, we can just collate them together, toss them into an extrinsic, throw it to a custom Substrate runtime module that is just going to verify all the signatures, verify all the state transitions, and verify that the player that won actually won, and then store that knowledge on chain. We can make certain optimizations, which I don't think are necessarily important to go into detail. But for example, you can, if you have a long game history, you can obviously prune that, for example, and send a shorter version as long as you have a two-player adversarial game and the loser actually signs, then you're kind of in safe territory to do something like that. So the other thing about making decentralized games is that it's not really like conventional game design where you actually have a central server that can dictate whether players are abiding by the rules. In this context, it's just the players themselves that have to be the judge for their peers, basically. So without this sort of third-party authoritative judge, you have to resort to schemes like commit reveal in order to ensure that secrets actually stay secret from your adversary in this sort of game context. So commit reveal applies to a number of different game mechanics. Just to name a few, for example, simultaneous move games like rock, paper, scissors, imperfect information games, which are card games like poker, or in our case, Skyweaver, where the cards are secret, or any other game of chance, basically, where you require unbiased random number generation. So the idea is that with Arcadium, we are trying to provide these primitives for free so that game developers don't actually have to worry about this stuff. Because it requires some mental gymnastics in order to remodel your game logic into this sort of, it's really a new paradigm since you don't really have this sort of central judge to keep everything in balance. So what's the Arcadium library going to do? Well, the idea is that you write your game in Rust once, and you can use those primitives, and then you compile it down to WebAssembly. And the great thing about that is, because Substrate also runs WebAssembly, you have some reasonable assurances that the code that you run in your custom Substrate runtime module is actually the same as the code that you run in the browser. So you only have to write your code once. You don't have to try and duplicate it. It's not prone to errors if in the case that you do end up duplicating it. So I think I'll start with a demo right now, just to. Yeah, just to demo like what we've started prototyping. I think something is. Okay, so I've already built this, but for those of you following along, this is very, very similar to how the custom Substrate runtime tutorial on the Substrate dev docs works. But I've already built it basically, And so what I'm going to do right now is I'm going to purge a chain, and then I'm going to like reload it. Okay, so this chain is this substrate chain is already running now, but it actually already has the WebAssembly module or the Substrate runtime module that will confirm game histories of rock, paper, scissors. So now that that's running, I will launch, I'll start up the Polkadot apps browser. Okay, and this is the apps browser that I think most of us have seen before. Nope. Okay. And now I will run a test case that sorry. Yeah. So what's happening here is that effectively there's sort of this process that's spawning two child processes. And the two child processes are each running their own implementation of this rock, paper, scissors game. They're actually different implementations. And what they do is they simply relay messages across the parent process. And they all are running the WebAssembly module that implements the game state of rock, paper, scissors. And eventually, one player comes to the conclusion that they won, actually. So actually, normally this test case actually directly sends it to the substrate chain, but I'm just going to take this, copy it, and then paste it into the yeah, I'm going to paste it into the Polkadot UI here. If I can, I guess it's extrinsics. Yes. And now I will send it directly to the runtime module. Submit that as a transaction. We'll see what happens. Ooh, it worked. Okay. Thank you. And finally, we can see our chain state was updated, hopefully. I mean, so we have this hash map results. So I can check the wins of any particular account. So this client here claimed they won, and that this is their address here. So we should see that this person has one win right there. And if we check their losses, Oh, whoops. I need to paste that there. Yeah, they have no losses because, I mean, generally, like, everybody starts off with 0 wins and losses. Anyways, so the question is, what does this look like for a game developer, actually? Oh, jeez. Sorry, I'm just trying to get my bearings here. Oh, that's 5. Okay, so what does this look like for a game developer? Well, these primitives that we provide, the idea is that, yeah, so the game developer only implements that top box there. And then the tooling generates the runtime module, and there's obviously Substrate that's over there. And then it also generates the WASM module. And then the game client can access that WASM module via a TypeScript library that we provide, and allows you to interact with the game logic as if it were a black box, basically. So in a lot of ways, Arcadium is kind of the barrier that separates. It's the abstraction that allows people to write games without actually needing to know too much beyond the actual logic of their game itself. So as far as actually implementing these types of games, it's a very simple interface. You implement a few functions. It's basically the same as a general state machine. You have functions that determine whether you're in a terminal state or whether you're in a non-terminal. And then you have your transition functions. We do separate the idea between validating actions for a particular state and applying a valid action to a state. Mostly because Rust has the idea of mutable versus immutable references, right? So the idea is that you don't want to really mutate things until you really know that you actually have something valid and ready to actually change the state. What does, for example, randomness look like? Well, right now in the prototype that we have, if you need random numbers, basically you just ask for them. You make this function call, and what you do is you pass in a closure or a continuation, and in that continuation you resolve what the next state should be based on a mutually seeded random number generator that's seeded via commit reveal. And here you can see an example of that. The next state is, I mean, there's more down here, but the gist of it is you basically make this call, and then you resolve the next state based on the randomness, and that's all you need to know. You don't need to know how the commit reveal randomness is actually working underneath the hood. Similarly for rock, paper, scissors, in this implementation, you can exchange secrets between 2 players, and you can ensure that the only way that you could actually manipulate this state is because the secrets were revealed effectively simultaneously, and you resolve the state based on that. So these patterns are just a couple of actually special case examples of this sort of secret sharing protocol. Like developers can actually extend this to devise their own ways of sharing secrets. For example, if you're writing a card game and you need to reveal the fact that, okay, you have this card and the way to reveal it is via Merkle proof. At that point, you can start to implement that primitive yourself if you need that kind of extensibility from the library. Anyways, that kind of concludes everything. Any questions?
Any questions from anyone? All right. Kind of more of a question/suggestion. So you're using a state channel for the game, right? And that processes the Rust encoded state transitions for.
Yep.
Okay. And you only use the player and the adversary for the state channel?
Yes.
Okay. Have you thought of, so in games or like competitive kind of games with card games are included, quite often you have spectators watching the game?
Right, yeah.
Did you think about like adding spectators' signatures to verify that you have like more, more actors involved in the game that also sign off that the game correctly has been, observed as well in this particular order?
It's not something I really thought about, but spectator signatures would basically
just like add more proof that this game happened and happened in this order.
I see. Yeah, so the issue I think that's of concern is the idea of sort of state forgery in a lot of ways. Like, for example, if I have two players colluding with each other, they're not actually adversaries in this instance. How do I actually know that the game occurred? How do I know that, for example, we didn't start off from this really strange state where one player had like 1 million health? Yeah, that's an interesting idea. It's something we could potentially incorporate. I think for our use case, we kind of assume that the two players are adversarial by nature. Right now, one of our main ways of mitigating this is via a matchmaking process that sort of introduces the idea that, okay, these are probably going to be two random players, and in that case, if they're random, there's a good chance that they don't really know each other, and therefore they have no real incentives to collude. But yeah, that's an interesting suggestion. I'll keep that in mind.
Cool. Well, thank you very much. Very cool demo.
Thank you.